So here now next point in the probability is this random variable and its probability distribution. So to define random variable, we start with a finite sample space. Let this as be a finite sample space. Finite sample space. You know, sample space is set of outcomes. Now what we do with the outcomes of this, you have outcomes here. With the outcomes of this sample space, we associate real numbers. We associate here real numbers. What we are going to associate? Real numbers. With outcomes of the sample space, we are going to connect the real numbers. So here, if I call the real numbers as x1, x2 up to xn, these are the numbers connected with, associate means what? Connected with the outcomes of the sample space. Then this set x is called here a random variable. Big X, that's the symbol. Random variable, RV, random variable. For example, if I take the sample space as this sample space associated with tossing a coin twice, let's write this as a sample space. How many times I tossed a coin? Twice. Okay, now what I'll do, with every outcomes I will count number of tails. So here number of tails is 0, number of tails 1, number of tails 1, number of tails 2 here. So what is definition of random variable? So here definition of random variable equals to number of tails that we have defined, remember. How to associate that we have considered. Random variable we have defined as the number of tails with each outcome. Number of tails 0, number of tails 1, number of tails 1, number of tails 2. So with every outcome you can see you have connected numbers. So here what is the random variable x with the 0, 1 and 2? The random variable associated with this is 0, 1 and 2. Fine, this is what the definition of random variable. Now here you can see what's the probability of each outcome. Probability of each outcome. There are 4 outcomes. So probability of each outcome will be 1 by 4. So here it is 1 by 4. Probability of each outcome equals to how much? 1 by 4. 0 is associated with only one outcome. So we say that the probability of random variable 0 is 1 by 4. 1 is associated with how many outcomes? 2. Here 1 by 4, here 1 by 4. So 1 by 4 plus 1 by 4, which is 1 by 2. And the probability of this one is again 1 by 4. So 1 by 4, 1 by 2 and 1 by 4. These are the probabilities of these 3 random variables. So its situation is like this. You have x equals to xi, that is 0, 1 and 2. These are the 3 random variable. Probability of each random variable like this. Here 1 by 4, this 1 by 2 and 1 by 4. Fine. We have expressed the random variable and the corresponding probability in this tabular form. What we did, we have expressed the random variable and the corresponding probability in which form? This tabular form, and such a tabular representation that is known as probability distribution. This is sometimes called probability distribution of the random variable x. 2 things we notice here. The first thing is obvious. Probability of each of random variable xi is greater than 0. That is number 1. And 0, 1 and 2 are elementary events. If you remember, sum of the probabilities of the elementary events is always 1. So this summation has to be 1. So summation of probability of each random variable is always 1. This is always true in a probability distribution of a random variable. Fine. I think this is clear to you. Random variable with the corresponding probabilities. So here I'll write like this: probability distribution of random variable x. Here x equals to, you have xi, that is x1, x2 and so on up to xn. These are the values of the random variable x. And here we have probability of each xi. So I'll write p of x1, I'll write p of x2 and so on p of xn. Fine. So we have this presentation in a tabular form. That's the probability of random variable x and the corresponding random variable in this, with these two things. Which two things? Probability of each xi is greater than 0. You can take 0 also sometimes for every I, 1, 2 and so on. And summation of probabilities sigma p of xi, that is p of x1 plus p of x2 up to p of xn, that is always 1. Sum of the probabilities is always 1, right, where I runs from 1 to n. So this tabular distribution with these two conditions is called, so this is called probability distribution of random variable x. So whenever we have the probability distribution, immediately we have two things in our mind. Which two things? That is, each of this probability should be greater than 0 and the summation of all this probability must be exactly 1. If any one of these two conditions doesn't hold, that means it's not the required probability distribution. Okay, you can see in that example which I have chosen here, random variables 0, 1 and 2, 1 by 4, 1 by 2, 1 by 4. Why 1 by 2? That you know, 1 by 4 twice. Why 1 by 4? Probability of each outcome, that is 1 by 4. You can see that this summation is exactly 1 and probability is here just greater than 0. So we keep these two things in our mind whenever we have probability distribution. Okay, now after defining this, let's write two more things here. Mean and variance of a random variable x. Mean is, as we have discussed, it is just like arithmetic mean only. So what we need to do, we need to start with the probability distribution here, as we have stated. So we have this probability distribution. We have probability distribution of a random variable x. So you have these n values, x1, x2 up to xn, and probability of x equals to xi, which is p of x1, then p of x2 and so on p of xn, right? This is, you know, standard probability distribution, and once I say that it's a probability distribution, immediately these two conditions holds true, right? That is there in our mind. This is a given probability distribution in a tabular form with those two conditions. Which two conditions? Each one is greater than 0 and summation is 1. Okay. Now we define mean, which is also called sometimes expectation of x. What it is called? Mathematical expectation, or just expected value, expectation of x, which is this into this plus this into this plus this into this, that is x1 into p of x1 plus x2 into p of x2 and so on xn into p of xn. That is mathematical expectation or mean, which you can write as sigma I runs from 1 to n xi into probability of xi, and this is here denoted by e of x, expected value, mean. This is mean, remember. So mean is denoted by which symbol? E of x. What is E of x? That is sigma I runs from 1 to n xi into p of xi equals to this Mean is given by this. What's the definition? Random variable into corresponding probability plus random variable into corresponding probability, and so on. Finally, xn into p of xn. So this is the formula, which is denoted by e of x into this we use, you will see. This is just same as arithmetic mean. Normally in arithmetic mean you have upon n, but that n is used under the probability, you know it very well. So one is this. Now we define the variance. We already studied, if you remember, standard deviation and variance and so on in statistic chapter in 11th standard. So it is just that only. So here we write without proof why the formula is this. So variance of random variable x equals to, it is, if you are interested you can refer the proof, but the final formula is this: e of x squared minus e of x the whole square. This is the variance of random variable x. Just you need to remember. Now e of x, you know, as I've stated, mean, but what is e of x square? So let me write, where e of x square means square of the random variable. Sigma I runs from 1 to n xi square into corresponding probability of random variable. Not the square of the probability. Please note here. Xi square into the corresponding probability. Not the square of the probability. Just square of the random variable. It's like this. Squared this, multiply with this, plus squared this, multiply this, squared this, multiply with this. And e of x, you know that we already stated. One more time I'm writing. E of x is sigma I runs from 1 to n xi into p of xi, that is e of x. So what's the variance of a random variable? E of x square minus e of x the whole square. Fine. So mathematical expectation, that is the mean, and here it is a variance. Okay, so with this three things, which three things? Variance, then we have mean here, and probability distribution. With these three things, now we go to next exercise, which is exercise 13.4. Let's start with this. The question number 1 there in this exercise 13.4, first question: state which of the following are not the probability distribution of random variable and give your answer. So immediately, whenever we have probability distribution, we need to check these two conditions. Probability should be greater than 0 and the sum of the probability should be 1. Now look at it first sub question. What do you think? Each of these probability is greater than 0. That's true. You can see. That's the first condition. And what about the second condition? Check their summation. What do you think about summation? If you check the summation, here in the summation is 1, therefore it is a probability distribution. Probability distribution. It is a probability distribution. Second one, in the second one, you can see that it is obviously not a distribution. Not a distribution. Why? It is not a distribution. Somewhere you have probability of some xi is negative. This is not possible, as we have this. This is not possible. So not probability distribution. What about the third one? Let's go to third one is the probability distribution. We are checking those conditions. Third one, what do you think? Their first condition, probability of each xi is greater than 0. And what about this? Sigma p of xi, this should be exactly 1. The third one, you have 0.6 plus 0.1 plus 0.2, right? And which is 0.9. It's not exactly 1, not 1. So not a distribution, not a probability distribution, not a distribution, probability distribution of x. I'm sorry, not a probability distribution of a random variable x. Okay, what about the fourth question? Fourth question, try just yourself. Check, you need to check those two conditions. The second question, an urn contains 5 red and 2 black. So total we have 7. 2 are selected randomly. 2 balls are selected out of 7. X represent definition of random variable x you are given. What is x? You are given number of black balls. Fine, that's given to you. What are the possible values of x? Now maximum you are going to select how many? 2. So either both are red, that means x is 0. If both are red, then what is x? 0. 1 red and 1 black, then what is x? 1. If both are black, then what is x? That is 2. So what are the possible values of x? So possible values of x, that is 0, 1 and 2. Right? That's the first question. Is it random variable? Yes. Yes, it is a random variable. It is a random variable. Why it is a random variable? Because here with every outcome you can associate numbers only. That's why it is a random variable. And the third question, you are given that a coin is tossed 6 times. How many times? 6 times. So outcomes will be like this. Right? You know you have 2 raised to 6 outcomes, which is 64 outcomes. Right? This is 64. Difficult to list all, but I'm just showing it would be like this. For example, all are H. 6 outcomes. Here all H. Then it is quite possible like this. 5H and 1 tail. Right? And so on. Then you may have 4H and 2 tails like this. Then you may have 3H and 3 tails. Right? Then you may have 2H and 4 tails like this. You may have 1H and 5 tails like this. And you may have all tails. Just I've shown for your information. Fine. So that way you have 64 outcomes. We want to write the random variable x. Just read the definition of random variable x. What is x? That is difference between these two. Difference between number of heads and number of tails. Here 6 minus 0. So maximum 6. 6 minus 0. So here it is 6. Okay. Here 5. 1, 2, 3, 4, 5 minus 1, that is 4. Head 5 minus tail 1, 5 minus 1, 4. Here 1, 2, 3, 4, 4 minus 2, 2. Here you can see 1, 2, 3, 3 minus 3 is 0. You try for this. 4 minus 2, 2. Take anything. This is 5 minus 1, 4. All tails. So 6 minus 0, 6. So these are the possible outcomes of random variable x. Number of heads minus number of tails, right? So difference will be here 6, 4, 2, 0. Now in the fourth question, we want actual probability distribution. There are 3 sub-questions. We are doing first. Find the probability distribution of number of heads, so that is x, in 2 tosses of a coin. So here sample space will be this. Coin is tossed how many times? 2 times. So this is a sample space, we know. Right? Number of h, that's the definition now. What is the definition of x of u? U means outcomes, equals to number of heads that's given to you in the question. Okay, so therefore what are the possible values of x? Here you have 2, then here you have 1. Here also 1 and this is 0. These are the possible values of x. Fine. So usually we write probability distribution. This is a random variable in this tabular form. I'll write here outcomes, that is U. You know, these are the four outcomes: HH, HT, TH and TT. Then we write here probability of each outcome. Probability of each outcome. What's the probability of each outcome? Total outcome is equals to 4. So probability of each of these is 1 by 4, 1 by 4, 1 by 4 and 1 by 4. Probability of each outcome is 1 by 4. Fine. And what are the possible values of the random variable? You know, here 2 with both of these 1 and here 0. Right? And now we write here probability of random variable x. Okay. So we already discussed this. What's the probability of 2? It is 1 by 4. Here 1 by 4, 1 by 4. So summation of these two, 1 by 4 plus 1 by 4, 1 by 2, and here 1 by 4. So this is required table. Now what we do, we just write as a final answer here. Therefore probability distribution of x, that is here x, which is 0, 1 and 2, and the corresponding probability, that's 1 by 4, 1 by 2 and 1 by 4. Right? This is what we express in form of table here. So we have this. You can see that each of these is greater than 0 and summation of this is exactly 1. That you can see obviously here. In the second sub question, you are given that coin is tossed 3 times. So sample space will have how many outcomes? 8 outcomes. A coin is tossed how many times? 3 times. So sample space will have, as you know here, these are the 8 outcomes and all are tails, we know. So what's the probability of each outcome? Probability of each outcome equals to 1 upon 8. Fine, there are 8 outcomes, so probability of each of these is 1 upon 8. Okay. Now we write the random variable. What is the definition of x in the question? Number of tails. Number of tails. So what are the possible values of x? Your tail is 0. Your number of tails is 1. 1, 1. So which I've written? 2, 2, 2. So next is 2. And then 3. So these are the possible values of random variable x. Now you can prepare the table here or you can write directly also, but I'll show this intermediate step. I'll write outcome here, which is u. Then I have here probability of each outcome, and here what we are going to write, next one random variable, and here you have probability of x. Fine. So here outcome is here HHH, then HHT. I'm just copying from there. Then HTH. Then this is THH. Then this is HTT. Then THT. Then TTH. And here you have TTT. These are the outcomes. You know it. Okay. Now probability of each of this, we know 1 upon 8 here. Random variable with this, that is 0 because definition is number of tails. With this 3, random variable is 1. With this 3, random variable is 2 here. And with this random variable is just 3. So here the probability with 0, there is 1 upon 8. Here 3 outcomes, 1, 2, 3. So 1 upon 8 3 times. So that's 3 by 8. Here 1, 2, 3, 1, 2, 3, 3 outcomes, so 3 by 8, and here just 1 upon 8. So therefore, finally, probability distribution of x, which I write in the tabular form here, 0, 1, 2 and 3. and probability of x, which is 1 upon 8, 3 upon 8, 3 upon 8 and 1 upon 8. That's probability of random variable x, right? We express in the tabular form. You can see that each of these is greater than 0 and their summation is. So let's see now next question. Question number 5 here. There we are given that a die is tossed twice. So we know sample space will have such x comma y, where x and y both are from where to where? 1, 2 up to 6. So total you have here 36 outcomes, which we know very well. Okay. In the first sub question, what is the definition of success? Success means random variable here. Definition of success, which is random variable x, that is equals to number greater than 4. Number greater than 4 here. Number greater than 4 here. So here you have two numbers, x and y, and random variable x is that the number greater than 4. So if for example both numbers are greater than 4, like 6, 6, 6, 5, then the value of x is here 2, right? If one number is like 6 and 1, so one number is more than 1, the other one is less than, more than 4, the other one is less than 4, so 1. And then suppose like 1, 1, then 1, 2, both the numbers are less than 4, so it is 0. So values of the random variable x are this: 0, 1 and 2. Either both numbers are greater than 4, one number greater than 4, and both numbers are not greater than 4, so x is 0. Now we, for probability distribution, we'll do like this. We list here outcomes. Then here we write probability of each outcome. Probability of each outcome. You know it is 1 by 36 because total outcomes equals to 36. And here random variable x. So over here, let me list out this. So first we are doing for random variable 0. So we list out all outcomes where both numbers are not greater than 4. So like this, 1, 1, see both numbers are not greater than 4. Then you can have 1, 2, then 1, 3, then 1, 4. Fine? You cannot take 1, 5. With these 4 outcomes, random variable is 0. So I'll write 1, 5 here. So here it is random variable 1. Okay? Then I can have here 1, 6. So random variable is 1 here. Then next number I'll take, next one I'll take 2, 1. See random variable 0. 2, 2. Then 2, 3. Then 2, 4. Okay? So here both numbers are less than 4. Then over here you can have 2, 5, 2, 6. So one number is more than 4. Random variable is 1. Next I'll go to here 3, 1. Then 3, 2, 3, 3 and 3, 4. You can see that here both numbers are less than 4. Then I'll have here 3, 5 and 3, 6. Fine? One number is more than 4, so 1. Then I'll go to next one, that is which one? 4, 1. Here 4, 2, 4, 3 and 4, 4. You can see both numbers are less than 4. So random variable is 0. Then I can have here 4, 5, 4, 6. Fine? Now you cannot take 5, 1 and so on here. So here I am going to write 5, 1, 1 random variable. One number is more than 4. 5, 2, 5, 3, then 5, 4. Now what about next? If I write 5, 5, both numbers are more than 4. So here random variable is 2. And what about 5, 6? Both numbers are more than 4. So random variable is 2. Then here next one, let me write here, which is 6, 1, then 6, 2, 6, 2, 6, 3, and I'll have 6, 4. One number is more than 4. Okay, and then over here I'll have 6, 5 and 6, 6. Fine, this is a list of 36 outcome. What is the probability of each of this, which is nothing but 1 by 36. Here 1 by 36. Now how many times this has occurred? 1, 2, 3, 6, 9, 12, 15 and 16. So if I write here probability of random variable x here, this is how many times? 16 times. So 16 by 36. So which is nothing but the 4 by 9. So probability of random variable 0 is 4 by 9. What about this? 5, 8, 11, 12 and 16. This is also 16 times. So probability of this one is also 16 by 36. So you will have again 4 by 9. And what about 2? This is just 4 times. So over here it will be 4 by 36. So 1 by 9. So this is our final probability distribution. 0 then 4 by 9, 1 then 4 by 9 and 2 then 1 by 9. Try question number 6 onwards. Otherwise I'll send in the next session.